All right, hey everybody, welcome to my presentation. Thanks for coming. This is Automate AWS with CLI and Shell Scripting. My name is Wes Novack. I am a Senior Systems Engineer at Pluralsight. So let's jump into the AWS CLI. CLI is the command line interface, obviously. It's a tool that lets you manage AWS services with one tool across the many services that Amazon has, which is fairly impressive because all of the different services have different service teams that manage and control those services. They all have different APIs, they all use different commands, and having one tool to interact with all of them is very useful and powerful. So how do you install the AWS CLI? The recommended method is with pip. You can do pip install AWS CLI --upgrade. And if you just want to install it for your user on the machine, you can use the --user parameter. After you get the CLI installed, the first thing you're going to want to do is a AWS configure. And if you are running AWS configure, you can run it straight without any parameters, or you can include a parameter like shown in this example that specifies a named profile, which I'm going to get into a little bit later as well. So after you run AWS configure, you're going to be prompted for your access key ID, and then your secret access key, default region, and a default output format. This, again, as I mentioned, is called a named profile. It's not necessary. If you don't include that profile parameter, it will just create a default profile for you. And that's fine if you only have one set of AWS credentials and one account to manage. You can just go ahead and just use the default profile. But if you have multiple AWS accounts to manage, or even multiple credentials to use in one account, maybe to test your IAM privileges with separate accounts and different IAM policies, then you're going to want to use named profiles so that you can easily switch between those different credentials that you have using the CLI. So I'm going to talk about the config files next that the AWS CLI uses. There are two files that the AWS CLI uses primarily. The first file is the home/.aws/config file, and that file specifies the default region and output format for each profile. And the second primary file that the CLI uses is the home/.aws/credentials file. And that file will store your secret keys for each of your profile, or just your default profile if you're just using one. So let's take a look at what these files look like. Here is an example of an AWS config file. You can see that we've got on a couple of lines here, we've got different profiles that are encapsulated with the square brackets there. At the very top, we've got the default profile, and that's what it will create if you don't specify a -- profile on the command line. But underneath, you can see it has profile dev, profile stage, profile prod, and those are the AWS named profiles. So if you wanted to use the credentials for those profiles, whenever you run an AWS CLI command, you would append that -- profile and then the name of that named profile, like dev. This is what the credentials file looks like. Again, it shows your profiles in square brackets, and underneath that it includes a key and value for AWS access key ID and AWS secret access key. Yes, these are fake, as I included as a comment on the bottom, so don't try to use my fake credentials here. Notably, this file contains your secret keys, as you can see here, which depending on if you are using keys that have admin privileges, these are basically the keys to the kingdom for your AWS account. And the CLI stores these in an unencrypted file on your file system. So you want to make sure that you use full disk encryption and you don't expose these keys or leak them anywhere accidentally, or else there goes your entire AWS account if you're using admin level credentials. So I'm going to talk about the configuration settings and precedents that the CLI uses. This is straight from the AWS web UI documentation. The AWS CLI looks for credentials and config settings in the following order. The first order is the command line options, And the -- profile was an example of that I gave earlier. So that's the highest level of precedence. If you specify -- profile something, it's going to use that no matter what anything else says anywhere else. The next level of configuration precedence is the environment variables. And you can basically configure anything that you want with your AWS CLI using environment variables. And on the screen here, it shows examples for AWS Access Key ID and AWS Secret Access Key and AWS Session Token. So you can use environment variables for that. I don't usually use those particular environment variables, but there are a few that I often use in scripting that I'm going to mention later. Next up is the AWS credentials file, and we looked at that just a few slides ago, and that's going to include your secret access keys locally on your machine. After that is the config file that we also looked at a couple slides ago. After that, the configuration precedence goes to container credentials, and this is only relevant if you're using the Amazon ECS Elastic Container Service or the Amazon EKS Elastic Kubernetes Service. Otherwise, you don't have to worry about container credentials. And then finally, in the final order of config settings and precedence, we have the instance profile credentials. So when you launch an EC2 instance in AWS, you have the option of specifying an AWS instance profile. Your instance profile is linked to a IAM role. And that is the recommended way to get credentials to an EC2 instance, because you don't have to put any kind of credentials on the file system when you use that method. The CLI or the API basically just queries Amazon when it does have that instance profile and role associated with EC2 instance, and obtains temporary credentials. And so you don't have to worry about rotating credentials or credentials getting leaked if you use an instance profile and a role. So you should always do that when you're using the CLI on an EC2 instance, so that you don't have to worry about managing those keys. So environment variables, we talked about this on the last slide in the configuration precedence. These are some of the environment variables that I have often used in scripting along with the AWS CLI. So we've got AWS_profile to tell your script which profile you want it to use. And that's the same as using that -- profile parameter that I mentioned earlier. And then AWS default region is another example here of an environment variable that I've used frequently in scripting. So if you do have a lot of profiles like me, you want an easy way to switch between those profiles. So you don't want to have to append that -- profile dev or -- profile prod on every single command that you call. So you can create a function like I have on the screen here that will switch profiles for you, and then you don't have to append that -- profile parameter on every single command that you run. So this is a bash function that I include in my .bash rc file, so that when I log in, this function is always available for me. I'm going to have code examples and a link to my GitHub repo, where I've put a bunch of the code that I have as examples in this presentation at the end of this presentation. So don't feel like you have to copy any of this down right now. If you want to use this function, you can just grab it straight from my GitHub repo and use it later. But essentially, what this profile is doing what this function is doing on the top line here, it's doing a quick parameter check. It requires a parameter of a profile name. So the very top line there with the if statement you see is it's saying if there's no positional parameters passed to the function, then it's going to abort and tell you, there's one profile name required that you have to pass this function. And then it goes to an elif. It checks to see if the profile that you have specified actually exists in your AWS config file. And then if it doesn't exist in that file, it's going to abort and tell you, that profile doesn't exist in your configuration file. And then lastly, it falls through to that last else statement, and it will export that profile that you specified because it found it in that AWS config file. And then any commands you run further in your session will use that profile that you've switched to using this function. Okay, so let's run some commands, or at least show some examples of some commands, just to get a little bit more familiar with the AWS CLI for those who might not have seen it. This is the this is an AWS, so every AWS CLI command starts with AWS. That's the binary for the AWS CLI. And then afterwards, the next piece, as you can see on the screen, it says EC2. In AWS CLI vernacular, they call that the command. But it's really just, you know, the API that you're calling, the service you're specifying for AWS. So they call that EC2, they call that the command. And then the next piece that shows as describe-instances on my screen here, they call that a subcommand. So in this case, we're calling AWS command EC2 subcommand describe-instances, and then we're including a optional parameter here for --instance-IDs, and then we're specifying an EC2 instance ID. So this is an optional parameter. Some AWS subcommands have required parameters. Some don't have any required parameters at all. This is an example of a command that doesn't have any required parameters. So if I was to omit the --instance-IDs parameter here, it would just try to essentially return a huge JSON output of every single EC2 instance in the accounts that I have configured in my creds in the region that it's querying. The next example here is for S3. AWS S3 is the command, ls is the subcommand, and here I'm specifying --profile prod. And remember, the command line is the highest level of configuration precedence, so even if I would have switched to another profile using an environment variable, if I use the --profile prod parameter on the command line here, that would override anything and it would use that prod named profile. The S3 command is notably one of the only AWS commands and set of subcommands that doesn't return in a JSON output format, and that was like one of the original, AWS service, and so they just never got around to converting that, or maybe they had this CLI output for it already before they standardized on returning JSON output for the rest of them. There's another AWS command called AWS S3 API, and you can do more things with that as well that the AWS S3 command can't do. Here's another example of calling an RDS command and the describe-db-instances subcommand. And then again, you can see I'm using a --region US-east1 parameter appended to that. So that would override any environment variables again, because that is the highest level of configuration precedence. So that's very useful if you have AWS objects in multiple regions and you want to query different regions to see what you've got in there. You could always just append the region onto your command to get data out of different regions. The next example here is AWS guard duty list-findings subcommand. And then I've got a --detector-ID parameter on there. This is an example of a required parameter for a subcommand. So if you don't specify a detector ID on this subcommand, the CLI will happily let you know that it is required and that it's not going to do anything until you do, or not going to return you any useful information until you do. Lastly, we've got the ELB v2 command and the create-load-balancer subcommand. And I've got a --name my pretty ELB, and that is a required parameter as well. So just another example of that. So if you're using the AWS CLI, just starting to, maybe you've used it and you just didn't know about it, you want to know how to get help, right? So the way to get help is to do AWS command help, just space help, or AWS command subcommand help. So what you don't want to do is do --help, which I do pretty much every time. So don't follow my example there and just do a space and space help, and that'll give you, all of the required and optional parameters for each command, or or for each subcommand. And then the example of running it just on a command, it'll tell you a little bit about all of these subcommands that are available for a service. So I mentioned earlier that most of the AWS CLI subcommands will return a big JSON output for you to take a look at and use if you can. So here's an example on the screen. I know you guys probably can't read it, but you get an idea of, this is the JSON output of a EC2 describe-instances subcommand, and this is not even all of it. Like, there's so much data, and this is only for one EC2 instance. There's so much metadata about an EC2 instance that you get, dozens and dozens of lines of JSON that you have to figure out what to do with. So I'm going to get to how to manage that a little bit better next. And so now we get to the good stuff. So the good stuff, what I've got listed here is using --filter using --query, which uses JMESPath query language. And that is also something that the JQ utility uses, if you're familiar with that. And --output text instead of outputting JSON. And command substitution and bash functions. So let's check some of those out. So --filter. So this is a parameter that you can use on every single, pretty much every single AWS subcommand that does JSON output. You can use --filter on. So in the example up here, I'm doing an AWS EC2 describe-instances subcommand, but I'm not specifying an instance ID like I did in a previous example. So if you recall, what this subcommand would do if you don't constrain it with an instance ID is it would try to return you information about every single EC2 instance in your account in the region that you're querying. So if you don't want all of that, maybe you want to use the filter parameter here. So in this case, I'm filtering by a tag of name, and then as you can see in the values equals, you can put your instance name in there. So if you know the name of your EC2 instance, the friendly name that you've given to it, but you don't know the instance ID, you can get information about it using filter and specifying the name this way. Okay, let's talk about query. Again, this is similar to the filter. Oh, one more thing about filter. Various subcommands in AWS support different levels of support for filter. Some of them only allow you to filter on maybe one or two pieces of metadata that an AWS object might have. Other subcommands have very, very robust support for filter, and you can filter on essentially any single piece of metadata that the object has. So that's one thing to be aware of. Filter is very useful, but it might not actually allow you to filter on the piece of information you want, depending on the subcommand you're using. So it's not universally useful for every single subcommand and every single piece of metadata. For query, you can really use it on any subcommand and make it useful. Again, this is the JMESPath query language, similar to the JQ utility. And in the example here, I'm again doing an AWS EC2 command, a describe-instances subcommand. I'm specifying an EC2 instance ID with the --instance-IDs parameter. And then I'm using query to dive into that JSON object and only return the private IP address. So if you recall on that previous slide, I had this huge JSON output that's even scrolled off the screen. We couldn't even see all the metadata about it. And you might not want all that information or need it. So using query, you can just extract that one piece of information that you need or that you're looking for from that JSON output. And this is how you do it as an example. So you take like the top level key of that JSON output, which is reservations in this example, and then you dive into instances and then private IP address to pull the private IP address out of that big JSON structure. Okay, so you can also do filtering with query. So you've got --filter, and remember, filter doesn't always support all of the pieces of metadata that you might want to filter on, but thankfully you can also filter with query, because the filtering with query is part of the JMESPath query language. So on the example up here, I'm doing an AWS RDS command, describe-db-instances subcommand, and then I'm doing a query, and in the green, as you can see on the slide here, I'm filtering on any instance that has auto minor version upgrade equal to true. And then I am only extracting the DB instance identifier. So this would allow me to quickly query AWS and get a listing of every single RDS instance in my account, in my region that I'm querying, that has auto minor version upgrade set to true, because maybe I want to turn that off, depending on how critical your production databases are and if you can tolerate those automatic version upgrades and the slight amount of downtime that they cause. Okay, so JMESPath, the --query parameter using JMESPath also supports functions. So again, JMESPath is a full query language. It has functions that allow you to manipulate that JSON even further. and rename things, order things, sort things. In this case, in the blue, I'm using a starts with function to only pull back objects with the metadata image location that start with this big long path of 0997201094777, which happens to be the official canonical AWS account ID, so that I only pull back AMIs that are published by Canonical, and maybe not some other Ubuntu AMI that some other organization had published. And then in the green, I'm sorting by image location. And then what this actually does is just pull down and then gives me the latest image that matches this criteria for the particular region I'm in. So if you want to find the latest Ubuntu 16.04 image, this query would allow you to do that. You can use filter and query together. So why would you do that? There are a couple reasons why you would do that. The primary one is because of the way that the query language filtering works. If you notice here, the big canonical account ID path here is surrounded by backticks, which is required by the query function filtering here. So you wouldn't be able to pass a shell variable into it. So if you wanted to do that and pass a shell variable into it and do some filtering, then you can do -- filter, and then you can see here I'm using a $instance_name shell variable to filter on, and then also using query to just pull out the private IP address. Then you can use output. That was another one of the things that I mentioned. So instead of just outputting in JSON, even if you're pulling out just the single piece of metadata like a private IP address, it's still going to treat that as JSON output unless you specify -- output space text. And what that would look like for a single piece of data is you just surround it in square brackets on different lines. And that's not very conducive to shell scripting, right? Or stuffing that value into a variable so you can use it later. So if you want to do that, you're going to want to use the -- output text. Okay, so command substitution. This is essentially what I was just talking about. Command substitution here is an example of me setting a shell variable named IP_address, and then I'm doing command substitution using the $parentheses syntax here with bash, and I'm calling the AWS EC2 command, describe-instances subcommand. I'm specifying an instance ID. I'm using query to only pull out the private IP address for this particular instance. I'm outputting as text. The whatever was returned from that command gets assigned to that IP_address variable, and then if I later echo out that IP_address variable, you can see I just get that single piece of IP address data out of that I wanted to. So if you're doing scripting, you want to use that later, that's very useful. All right, so functions. I have a lot of AWS CLI functions inside my .bash RC file as well, so that I can quickly do most often EC2 lookup type functionality. So in this example on the screen, I've got a function named getIDFromName. And then at the top here, you can see, again, I'm using command substitution to assign the output of my AWS CLI command to the variable ID. And then at the bottom, I'm going to echo out the value of that ID variable after it gets set by the AWS CLI command. So this allows you to do really useful things, like if you know the name of an EC2 instance and you want to get its EC2 instance ID, which is the unique identifier within AWS that looks like some kind of hash value, you can do things like this. So here, again, I'm doing AWS EC2 describe instances. I'm filtering on the name tag, and I'm passing in a $1 positional parameter to filter on. So when you call the function, you would say get ID from name space, put a name there, and then it would query AWS, and it would return the instance ID only using that query, JMESPath query language, and then output as text, assign it to the ID variable, echo out that ID variable, and then you would quickly be able to get the EC2 instance ID if you only knew the name. And I have lots of functions just like that to get the IP address from a name, get the name from an ID, get the IP from an ID from IP, all kinds of variations on that, and they're in the GitHub repo that I'm going to have linked at the end of this presentation too. So check those out if you need to look up EC2 information frequently. They're very useful. Okay, so let's put some of this together and look at some scripting using the CLI and some shell scripting. All right, so I've got a function up, a shell script up on my screen here that I'm going to speak to. At the very top of the function, I'm using the set-e directive in my shell script, which tells my shell script to exit if any of the commands return a non-zero, non-successful return code. So that allows me to do some things later in the script, which I'll show. And the first thing I do is I set the ID variable equal to $1, which is the first positional parameter that you pass to the shell script. This is a reboot EC2. We start over. This script allows you to easily stop and then start an EC2 instance. So this is a common task in AWS, especially when the underlying hardware has a problem and they ask you, they tell you you're going to have this maintenance coming up where they're going to stop and start your hardware for you, or you can do it ahead of time, so you can schedule it on your own. So instead of using the AWS Web UI, you can use AWS shell scripting to do this yourself. Again, the first thing we do is we pass a EC2 instance ID to the script, and that gets set to this ID variable. Second thing we have here is a sleep duration. We've set that to 5. It's just a variable we're using. Start time is the next variable, and we set that to the date in seconds. We're going to use that later when we just calculate how long it took for our reboot to occur and display that to the user. The first parameter, the first function we have in the shell script is a check parameter script. So again, this script requires a positional parameter to be passed to it. So you call the script and then you pass it an EC2 instance ID. What this first function does is it checks to make sure that you're passing a first positional parameter to it that looks like an EC2 instance ID. So I'm using regex Perl compatible regular expression here to make sure that the positional parameter looks like I dash, some alphanumeric string that is 8 characters or more, because that's what EC2 instance IDs look like. And if that occurs, we return 0 so that the script can continue. If that does not occur, then we echo out that the instance ID parameter is required, and we give an example of what an EC2 instance ID looks like, and then we return 1, and that causes our script to exit because we have set that set-e directive at the top of the script. The next function we have defined in the script is the stop instance function. This is a very simple function which calls the AWS EC2 command, stop-instances subcommand, and then it uses a parameter of --instance-IDs and a $1 positional parameter that gets passed to the function, which is going to be the EC2 instance ID that you're telling AWS to stop. The next function I've got is start instance, very similar to the last instance, doing the same thing. Instead of stopping the instance, it is starting the instance. Next function up, we've got a check status function. And what we're doing here is we're calling the EC2 command again, but this time we're doing a describe instances subcommand. We're passing the instance ID as the first positional parameter, and then we're using query to pull out the state.name of the EC2 instance. So we're just checking the state of this particular EC2 instance. We want to know what the state is. The state can be running, it could be stopped, it could be starting, it could be stopping. Next function is check running. First thing we do in this function is we set a status variable to the output of the check_status function. So this is going to set the value of the status variable to whatever state the instance is in, if it's running, stopped, starting, stopping. After we get to the status of the instance, we dive into an if statement here that says if the status is not equal to running, then we're going to echo out a message that says can't restart the instance, its state is not running. And then we're going to return with a 1. And again, that's going to cause the script to exit because of that set-e directive, set-e directive we have at the top of the script. So the thinking for this particular script was that if you're going to stop and then start an instance, if it's not started, you might not want, you might want to be alerted that the instance isn't running already. Scroll down here a little bit in the script. We're almost done. The next function is wait for status. So this is pretty much the coolest function in the script, really. What we're going to do is we're going to set status to the output of the check status function again, similar to what we did before. So status is going to equal running, stopped, starting, or stopping. And then we enter into a while loop, and we're going to say while the status is not equal to positional parameter 2, we're going to do echo instance state is not yet the positional parameter of 2, and then we're sleeping. We're going to sleep for the sleep duration. We set that to 5 seconds above. And then we're going to call that status equals variable again, call the check status function again. So what you do with this function is you pass the instance ID and then you pass the state of the instance that you want the instance to be in. So you could do instance ID stopped, and then it's going to continue through that loop, keep checking the status of that instance until it's stopped. So you can see here I'm highlighting that part in the main runtime of the script where it calls the instance ID and then it calls the state, it passes it the second positional parameter of stopped, so that when it enters into this, well, it checks the status of it first, and then it enters into the while loop, so that until that instance is in a stopped state, it's just going to keep sleeping and echoing that the instance state is not yet stopped. So this allows you to continually check to see when that EC2 instance gets into the state that you want it to be in. And you don't have to keep clicking refresh on the AWS web UI like you might have to do otherwise. So that is the gist of the reboot script that I wanted to demo. Again, the first thing there, as you can see in the main runtime at the bottom, is it checks the parameter, makes sure that you're passing it something that looks like an EC2 instance ID, checks to see if it's running, stops the instance, it waits for it to be stopped, then it starts the instance, then it waits for it to be running, and then it calculates an end time, it calculates a duration, and then it echoes out a message that says your restart is complete and it took this many seconds. So if you're going to do it manually, you'd have to do something like this. You'd have to go to the AWS EC2 web UI. You have to find the EC2 instance that you want. And if you guys use the web UI, I'm sure in EC2, you're probably very familiar with this. You have to go to that actions menu. You have to go to instance state. You got to click the state that you want the instance to get into. It's going to prompt you, are you sure you want to stop these instances? So there's a lot of different clicking that you have to do if you're going to use the manual UI method here. Then you got to click yes stop. You can see the instance state enters into a stopping state there, but the UI doesn't really refresh for you, so you actually have to click that little refresh button on the top right. And if you want to make sure that your instance is stopped and then started in the very least amount of time, you really have to be diligent about just like hammering that refresh button, right, to make sure that you get it exactly when it's stopped so that you can start it real quick, right? So if you have a critical host that you want to make sure you get it back up right away, it's a lot more beneficial to use that script so that it'll start it right away without you having to, watch it, right? With this, it requires your full attention. You have to sit there and hammer on the refresh button, and then once it's stopped, you got to start it. But with a script, you can just start it and then walk away, and it's just going to stop the instance and then start it back up, and it doesn't require your attention. It's going to do the right thing. So we're still clicking refresh over here. I've clicked refresh maybe 10 times, and now finally it's entered into a stop state. So only then in the web UI can you go back up into actions and then go into instance state and then click start again to get that instance stopped and started. And that migrates an instance to new hardware. Whenever you stop an instance in AWS, it migrates it to new hardware. So whenever you have underlying hardware issues, you have to do that stop start. Just a reboot doesn't do that migration. You actually have to stop it and then start it. So again, when you're starting it again, you get back into the same situation. You can see the instance state is pending for a little while there. You have to keep hammering that reboot, that refresh button if you want to make sure that it resumes a running state like you wanted it to. So that's not as fun as the scripting method. So let's take a look at what it looks like if you actually run that script that I walked you through a second ago. So here, the top one, I'm demoing that function where I get ID from name. So I passed the linux-ftw EC2 instance name, and it gave me an EC2 instance ID from that. And now I'm calling that reboot_ec2.sh script that I was walking you through earlier, with the instance ID as the first positional parameter. You can see the first thing it does is, well, it's not the first thing it does, but it goes through the script, it stops the instance, it issues the stop command. You can see that it's stopping. Then it enters into that while loop that we talked about earlier. But the instance state is not yet stopped, so it's going to sleep. It's going to keep checking the AWS CLI until the instance gets into a stop state. So it's going to sleep, stopping. It's not stopped yet. Going to keep going, keep checking it. And again, there's that sleep duration that we had in there at 5 seconds. You can adjust that to whatever you want, but 5 seconds is usually pretty good. Here you can see it's starting. It's gone to starting the instance. So it's detected that the instance entered into that stop state that we wanted it to be in. And then it can issue that start command. So again, you didn't have to sit there and click refresh and wait for it. It's doing all the fun stuff for you there. Now it's starting the instance, and it's entering into that while loop again, checking the AWS EC2 instance state, waiting for it to get into a running status so that it knows that this reboot process has been finished. So there we go, the script finished there. You can see now after it detected that the instance got back into a running state, that it echoed out a couple messages. It says your restart of instance ID is complete, and this script completed in 64 seconds. Okay, so there's also this utility called the aws-shell that I wanted to mention, and this is something that I learned about in preparation and research for this talk. This is a utility that has been in developer preview for I think over 3 years. So take that as you will. It's interesting. The main advantage of using aws-shell is that it gives you autocomplete for subcommand names, and it can also give you autocomplete for even your resource IDs in your account, which can be very useful. When I tried it, it really threw me kind of for a loop because I'm so used to typing AWS and then my command. When you're using this aws-shell utility, you don't have to type AWS. They kind of put that behind the prompt. You just have to type your command and then your subcommand. I also had trouble installing it. Couldn't get it installed until I installed it into a virtual environment, and then it started working for me. So, you know, caveat emptor on using the aws-shell. Maybe you'll find it useful. Maybe you won't, but I wanted to mention it. So a couple suggestions on scripting with the CLI. Use a completely separate and isolated AWS account to dev and test your scripts. You can easily make things, do things that maybe you didn't intend to do, and things could go wrong very easily when you're testing and deving out a new script. So use a dev account that doesn't have your production resources in it. Make sure you're using the right named profile when you're doing that, or the right set of credentials. Never put your AWS keys on hosts or in apps. Again, you want to use instance profiles and roles. If you're using containers, you want to use those container credentials instead. Rotate your keys regularly. So if you have, especially your privileged keys that you admin access, you want to rotate them on a frequent cadence, maybe every quarter. And encrypt your hard drives because, again, those credentials are stored in plain text in a configuration file. Other things to note: you can check your AWS CLI version with AWS --version. AWS is a tremendously fast-moving ecosystem, right? They're launching new services every week, or features, right? So even old services that maybe you've been using for a long time, they get new features all the time, which means new subcommands will pop up into the AWS CLI. So you want to keep that up to date so that you get access to all of the new features and new services. So to upgrade your AWS CLI, you do pip install --s upgrade AWS CLI. If you want history enabled on your AWS CLI, you can do that with AWS configure set CLI_history enabled. And then if you have that turned on, you can access your history with AWS space history, space list. I've got a bunch of references here in the slideshow. I'm going to have a link on the last slide that includes a download of this slideshow if you want to look at anything in here and all the links that I've had. Any questions?
Got one for you for your experience, actually.
Sure.
So I don't recall if this is actually the case, but I seem to recall that one of the differences between filter and query is the amount of data that it initially returns back to the local Python before parsing.
Yep.
Like, is that actually correct? Like filter actually parses server side?
I think you're right. Yeah. So filter should be quicker.
Yeah.
Than query. Yeah. I think what happens is when you do query, it gives you the whole. It returns the whole thing and then parses it locally. Yeah.
Yeah. That's what I seemed to recall.
Yeah.
So I know that in the past I've actually done stuff where I was iterating over environment. I then just store the initial JSON output and then just use JQ to strip down to be able to iterate in bash over that. So.
Yep. Is that before query was available? Like I used to use JQ.
In this case, it would be to essentially cache the output. Because in either case, and that's another thing, there's no real in the AWS CLI. It doesn't like cache results. So that's just another thing.
Gotcha. Yep. Yeah, I used to use years ago they didn't even have the -- query functionality, so I used to use JQ then. And then when I introduced query, I just switched to that, so I wouldn't have to rely on another utility being installed.
I forget what it was I was doing with that. It had something to do with just rebooting the entire environment. So
yeah. So this I also want to mention that the example I showed here with just stopping and starting an EC2 instance is just a very simple example. There's a lot of powerful things you can do with AWS scripting. You can schedule the shutdown of your non-production environments on certain hours. You can manage lots of different things using the CLI and scheduling commands to run. So
sorry, ignore me.
No worries. Anybody else? Any questions? Yeah.
Good use cases for guard duty. Like what would you use scripting for guard duty?
Guard duty.
Because it returns a ton of stuff. So.
Guard duty is interesting. What I don't like about guard duty is that in the UI, it doesn't tell you finding IDs, right? Like you can't see those in the UI. So what we do with guard duty is we have a Lambda function that triggers off of guard duty events. And then when a guard duty event occurs, we post that information to a Slack channel so that we get kind of guard duty alerts that way. And when we get those, if we want to look at more detail on the alert, or the finding, I guess, right? They call them findings. I've found that the CLI is the easiest way to get the detailed information back on that finding, if you need to do more research on it. So I haven't done really much automation. I've just done more like looking up details on findings that have showed up. Yeah. Anybody else? Questions? Cool. I've got the presentation online here. It also has a link to my GitHub repo in there. So if you're interested in using any of the functions or the aliases that I've demoed, including that EC2 stop-start script, you're welcome to go check it out on my GitHub profile. And I am on Twitter as Wesley Tech. If you want to talk to me, follow up with any questions or anything, I'm always happy to chat about this stuff. This is what I do every day. So if you get into a more complex scenario where you need to do even more, then you're probably going to want to look at using Python and Boto3 to do some scripting with AWS. So a lot more powerful stuff you can do there as well. But the CLI is a little easier to work with for quick and dirty stuff for sure. So.